Good morning. In today's class, I am going to talk about the list of experiments in the physics laboratory. There exist some 5 to 6 experiments are there, that is first one is torsional pendulum. By using torsional pendulum, we have to find the moment of inertia and rigidity modulus of the given wire. And the next one is Young's modulus non-uniform bending method. So by using this non-uniform bending method, we can find the Young's modulus of the given material. And by using laser, we can find out the wavelength as well as particle size. And then by using spectrometer, we can determine the wavelength of the mercury spectrum, that is Webber lines. And also one heat experiment is there, that is by using least disk apparatus, we can find the coefficient of thermal conductivity of the bad conductor. So these are the experiments we are going to do in the physics lab. So some 7 to 8 experiments are there. So we only do the first 5 experiments. Okay. So before entering into the experiments, there are some preliminary apparatus we are using in the laboratory. So the first one is the first one is screw gauge. And the second one is vernier caliper. Third one is traveling microscope. And the fourth one is spectrometer. So these are the preliminary apparatus that we use this screw gauge vernier caliper while doing this torsional pendulum, and that is a thermal conductivity of a bad conductor, and also the Young's modulus experiment. Okay. So first I will explain this screw gauge. So look here. So this is the instrument, screw gauge apparatus. So here there are two scales, and this scale is called as, if you unscrew this, you could find one horizontal scale. This scale is called as pitch scale, and which one rotated like our head, this scale, that is circular scale, or otherwise it is called as head scale. And this is nothing but, this is a frame, this is a screw, and this is ratchet, and this is stud, etc. Okay. So we should have some, you should know the least count value of this apparatus. So the least count, coming to the least count, so what do you mean by least count? Means that is the least value up to which the instrument can be, or the apparatus can be used or measured. So for this screw gauge, the first one is screw gauge. So the least count for screw gauge is 0.01 millimeter. And coming to the second one, vernier caliper, 0.01 centimeter. For vernier caliper, 0.01 centimeter. And for traveling microscope, that is equal to the screw gauge, that is nothing but 0.01 mm, but we can write it as 0.01 centimeter. Why we write in centimeter means because the readings are graduated in centimeter in traveling microscope. And the last one is spectrometer, that is 1 minute. You can say this as 1 minute, don't say as 1 dash something like that. So it is 1 minute. So you look here. So the first three apparatus, we have the least count values in decimal, like millimeter, centimeter, 0.01, 0.01 centimeter, and 0.001 centimeter. But this is the only apparatus having least count as 1 minute. So first three instruments, that is, they are having the scale as linear. there is a linear scale. The only apparatus having circular scale is spectrometer. So here we have degrees and division. So we got the least count as 1 minute. So I write it as that least count is for screw gauge 0.01 mm and for vernier caliper 0.01 centimeter, something like that. And you may raise the question, how you got this value was 0.01 mm for screw gauge and 0.01 centimeter for vernier caliper. So there is a formula, there is an expression to find this least count value. So for screw gauge, so that is least count is equal to pitch by number of head scale divisions. So this is the formula for the least count to find the screw gauge. That is least count value of the, that is how you got it as 0.01 mm. I will explain. So this is least count is equal to pitch by number of head scale division. So if an instrument is given to you, you could easily find out the number of divisions in the, this is I said this is the head scale. So you can look at and simply write it as the number of division is equal to 100. So you don't know what is pitch then. So pitch is nothing but, suppose if I want to move, so here some, that is the readings are 1, 2, 3, 4, 5, some 20 to 25 mm are there. So in pitch scale each line is 1 mm. Suppose if I want to move 1 mm in pitch scale means I have to give complete one rotation in the head scale. So pitch is nothing but distance moved by number of rotations given. If I want to move 2 division or 5 divisions in pitch scale means I have to give complete 5 rotations. So that is equal to 1 mm or 2 mm, for example 2 mm means I have to give 2 complete rotation. Anyhow the pitch value is 1 mm. So pitch is nothing but 1 mm, whatever it may be. If you want to move some 6 division means you have to give complete 6 rotations. So now substitute instead of the pitch is 1 mm. So least count becomes, so 1 mm divided by 100, that is equal to 0.01 mm. So by this way you have to find the least count of the screw gauge. So you know least count form, this is the only apparatus having different least count formula. The rest of the 3, the remaining 3 have the same least count formula. Okay. So pitch by, here we have two scales, one is pitch scale, this one is pitch scale, and which one rotated like our head or circular scale or head scale. So I write it as pitch by number of head scale division, and pitch is nothing but I said distance moved by number of rotation given, and you substitute the values and we got it as 0.01 mm. Okay. So next we go to the vernier caliper. So I told that is the remaining 3 apparatus, that is vernier caliper, travelling microscope and spectrometer having same least count formula. For vernier caliper, travelling microscope and spectrometer. So least count is equal to, I will show the vernier caliper, and here there are 2 scales. This one is, the lengthier one is main scale and the small one is vernier scale. So this is main scale, and this part is vernier scale. So least count is equal to value of one main scale division, by total number of vernier scale. So if I give this vernier caliper, you could find out the number of divisions in vernier. So it is almost 10 divisions. So it is equal to 10 divisions. So the number of division in vernier is 10. So value of 1 MSD by 10. Already I told that least count value is 0.01 centimeter. So in order to find this value, if you don't know how to find it through the instrument, you can take a calculation like this. So you know the least already that is earlier I written that the least count values are the first 4 preliminary apparatus, and for vernier caliper I wrote it as 0.01 centimeter. So least count is 0.01 centimeter. You don't know the value of main scale division. So in order to find this value of this one main scale division, you cross multiply these two, you can get the numerator value. If not, so look at the apparatus. So in between, that is the readings are entered in centimeter. So in between, that is 1 centimeter contains some 10 divisions. So to find the main scale division, one centimeter is equal to, the apparatus is given to you, you look at the apparatus and you can easily find out 1 centimeter contains 10 divisions. So 1 division is equal to 1 centimeter divided by 10, that is equal to 0.01 centimeter. 0.1 centimeter. So the value of one main scale is now 0.1 centimeter, and substitute in the formula. Therefore, the least count is equal to 0.1 centimeter divided by 10 is equal to 0.01 centimeter. So this is the least count value for the vernier caliper. And you have to apply the same formula for the spectrometer as well as traveling microscope. Okay. So what is the use of this screw gauge and vernier caliper? So by using screw gauge, you can find the thickness of any object. Suppose if you want to find the thickness of the scale, so you have to keep the scale, whatever may be the object, so you have to find the thickness that is less than 0.01 mm, because the least count value is 0.01 mm only. So you cannot find the thickness that is less than 0.01 mm. Okay. So you have to fix the scale like this, and then you have to note down this pitch scale as well as head scale. And before start doing this using the screw gauge, you have to note down the zero correction and error. So how can you find this zero correction and error? And the screw gauge is given to you. Before start doing the experiment, we should note down the zero correction and error. So after giving full tightness, if the 0 of the head scale exactly coincide with the 0 of the, that is the heights coincide with the horizontal line of the pitch scale or 0 of the pitch scale, then there is no error. This is no error. If there is no error, there is no correction, no error and no corrections. So look here, this is a line, it is marked as 1, 2, 3 something like that. It is the horizontal scale, that is in the pitch scale. I said each line is 1 mm. Okay. So after giving full tightness, full rotation, both the line coincide like this. The 0 of the head scale exactly coincide with the horizontal line of the pitch scale, then there is no error. If there is no error, there is no correction. And coming to the next one, that is positive correction. So here look at this. So the 0 lies above the horizontal line. So horizontal line of the pitch scale. So in such cases, that is if the 0 comes above the horizontal line of the pitch scale, the correction is above, means remember above means positive correction, and correspondingly the error will be negative, opposite to the corrections. Okay. So the correction is and error is, therefore error is negative. So this may be 95, 90. So the horizontal line got coincidence with this 94th line. Okay. So you have to subtract this 94 from 100. So the correction is positive correction. So that is plus 6 divisions. So the correction is plus 6 and error is minus 6. And immediately you have to multiply this 6 with the least count value. So the correction is equal to 0.06 mm. Don't bother about this error because you are going to carry out this correction value only. So after getting the divisions, whether it is positive or negative, you have to multiply with the least count values. Okay. So it is 0.06 mm. So in the tabular column, you have to, if it is a positive correction, means you have to add 0.06 mm at the corrected reading, or if it is negative correction, means you have to subtract the value from the observed reading. Okay. And this is the positive correction. And coming to the negative correction, and look here, look at this diagram, and the 0 comes below the horizontal line of the pitch scale. So here the correction is negative. So if the 0 comes below the horizontal line of the pitch scale, the correction is negative and hence the error is positive. Okay. So here it got coincide with the fifth division. This is 5, 10, something like that. So the correction is -5, and I said I have to multiply with this least count value, so it is 0.05 mm. And corresponding the error is plus, this is minus 0.5 mm and the error is plus 0.5 mm. Okay. So I think you could understand this error and correction. So both exactly the same coincidence means no correction, and if the 0 comes above the horizontal line means correction is positive, and below the horizontal line means the correction is negative. Okay. Now we will find out the thickness of any given object. Okay. I took the scale as the object. So you have to insert the scale between these two jaws and fix tightly. Like this you have to fix. Any given object should be fixed like this. Okay. So note down the number of divisions in the pitch scale, that is the pitch scale reading, and note down the which line of the head scale got exact coincidence with the horizontal line. It may be some 60s or 50s or 93 or 78, something like that. Okay. So yeah, after note down the pitch scale and head scale, you have to enter the readings in the tabular column. So I will draw the tabular column to find the thickness of, or you can find the thickness of, that is the radius of the given wire, or you can find out the thickness of the that is scale or rubber or anything, some this part, anything maybe. I took the example as the scale. Okay. So serial number. Pitch scale reading, I simply write it as PSR, pitch scale reading, PSR into 10 power minus 3 meter. So everything you have to convert into, because we are following the MK system, so you have to convert into meter, kilogram and second. So it is in millimeter, so millimeter to meter conversion becomes 10 power minus 3 meter. So pitch scale reading. Then head scale coincidence. It should be in division, right? I said total number of division in head scale is 100. So it should be in division. So I put division. Then observed reading, OR means observed reading. So observed reading is nothing but, how will you find this observed reading means pitch scale PSR plus HSC into least count. So observed reading is equal to PSR plus HSC into least count. Okay. So the last one is correct reading. It is in 10 power minus 3 meter, and this is also in 10 power minus 3 meter. So this is corrected reading is nothing but observed reading plus or minus 0 correction. So if it is a positive correction, means at the last column you have to add that value or you have to subtract the value if it is negative correction. Okay. So for example, if I get 5 divisions in the pitch scale, means I simply write it as 5 number of lines in pitch scale. Note down the number of lines in pitch scale. If it is 5 means you simply write it as 5 divisions, and note down that is the coincidence in the head scale. So that is 71. 71 or 28 or something like that. Okay. So observed reading means pitch scale reading. This is the pitch scale reading. So 5 and HSC into least count. So you have to multiply this 71 with that of the least count. So you know the least count is 0.01 mm. If you multiply this 71, so it becomes 0.71, and you have to add to this pitch scale reading. So I simply write it as 5.71. Do you follow that? So pitch scale reading is 5. You have to multiply with this head scale division with the least count. So it becomes 0.71, and then you have to add to this pitch scale reading. So it becomes 5.71. So if I got this 0 correction, so first you should note down the 0 correction and 0 error. If there is no error, so you simply put it as nil, and correction is also nil. If there is any positive correction, for example, if I got 0.05 m plus, this is the example only. So I have to add this 0.5 mm to this observed reading. So while adding, so that's why I asked to immediately multiply with the least count value. If we keep the number as it is, you simply add that 5 to this pitch scale reading. It's wrong. Okay. So if it is in decimals, then you simply add after decimal only. So I have to add this 0.05 mm with this 0.71. So 5.71 plus 0.05, it becomes 5.76. You got it? Okay. I'll go with another one example. Suppose if I get that is 8, okay, and this is 28 or 26 or 20, something like that. So what is the observed reading? 8.20. And if I got this correction as negative, for example, if I take the correction as negative correction, for example, it is equal to 0.02 mm, it is in minus. So I have to subtract that 0.02 from this 8.20, so it becomes 8.18. Understand? Okay. So by this way, you have to find the thickness of the any object or the radius or diameter of the any object. So if the object is same, you can get almost the same pitch scale divisions. Okay, and by giving the pressure, that is the pressure may be differ. So that head scale coincidence may be 1 or 2 divisions or 5 divisions may change. Okay, so after then you have to take the average of all the 3 readings or 5 readings, whatever it may be, and take that average. That is the thickness of the particular object. Okay, so like that you have to find the thickness or diameter of the any object. So this is the complete tabular column for the screw gauge. And next I will move to the vernier caliper. I said this is the only apparatus having scale as pitch and head. Then the remaining 3 apparatus having the same scales like main scale and vernier scale. So what is the use of this vernier? So by using this vernier caliper, you can find out the breadth. So like this. So in vernier caliper, look here. This is the lower jaws and this is the upper jaws. By using this lower jaws, you can find out the outer diameter, and by using this upper jaws, you can find the inner diameter of the lid or water bottle lid or cover. Okay. So generally it is used to find the breadth of the object. So you have to fix like this. Okay. And remove this. First you should note down the main scale reading. So in order to note down the main scale reading, where the first line of the vernier, I said there exists some 10 divisions in the vernier scale. So look here, where the first line of the vernier got coincidence with the main scale, it got coincide with the 2.9 or 2.8. Okay. So while using this vernier caliper, you can get some decimals, but in screw gauge I said each line in pitch scale is 1 mm, so there is no decimal, you should not get any decimal. Okay, it's wrong. So it is 2.8, and this is the main scale reading. Suppose if the breadth is something like that, so it comes around 5.1. Okay. And after note down the main scale, out of this 10 divisions in the vernier caliper, which line got exact coincidence with the main scale? So it should be below, above 0 and below 10. So that is the vernier scale reading. Don't write it as 20 or 30 something like that, because the number of divisions in vernier scale is only 10. So you should write the vernier reading as, that is number of divisions in vernier scale is below 10 and above 0. Okay. So it may be, if I, for me it comes around 2, or some other person it may be 2, 3 or 5 something like that, it differs. Okay. So I will draw the tabular column for this vernier caliper to find the breadth of the beam. So here there is no correction and no error. Okay. So only you can get correction and error while using this screw gauge only. So you write simply 0 correction is nil and error is nil. This is MSR, means main scale reading. Okay. And what is the least count for this vernier caliper? It is 0.01 centimeter. So centimeter to meter conversion means you should put 10 power minus 2 meter, centimeter to meter conversion. But in the previous case I put 10 power minus 3 because the least count is 0.01 millimeter. So millimeter to meter conversion is 10 power minus 3, and here it is 10 power minus 2. So MSR. So next one is, another scale is vernier scale. So vernier scale coincidence, VSC. It is in division only, like our head scale. And similarly you write it as, that is observed reading. Observed reading is nothing but MSR plus VSC into least count. And the last one is correct reading. So correct reading is nothing but observed reading plus or minus 0 correction. Here there is no correction and error, so simply you write whatever the reading you got it as observed reading, that is the corrected reading. Okay, it's very simple. So for example, if it is 2.7, this is example only, 2.7. I said the division vernier scale, it should be below 10 only, so I write it as 8. So observed reading is nothing but 2.7, and this 8 should be multiplied with the least count. So you know the least count for the vernier is 0.01 centimeter, so it becomes 0.08. So 2.78. Simple. And correct reading is, as it is, you write 2.78. If I go for the same object, we asked to take readings at 3 different paces like this. You have to fix, and here, okay, 3 different paces you have to take reading. So for the second time also I am getting as 2.7, but the coincidence little differ, it comes around 6. So I simply write it as 2.76, and the observed reading, that is the correct reading. And the for third position, once again I got it as 2.7, and it may be some 5 or 8. Once again I will get it as 8. So it is 2.78, and here also 2.7. So this is for the same material. If you go for the different material, definitely that main scale and vernier scale will differ. Okay. So take average of all the 3 readings, and that is the breadth of the beam, and you should write 0 correction is equal to nil, and 0 error is equal to nil, and you write least count is equal to 0.01 centimeter. Okay, you go for the average of the 3 readings, and the average should be divided by, if it is 3 readings means that value should be divided by 3. So most of the students committed the mistake like this by simply adding all the values and put it as put the value as it is, and they call it as that is the breadth of the beam. So you have to, don't forget, after adding all the 3 values, whatever, if it is 3 or 5 readings means you have to divide that value by the number of times, that is 1, 2, 3 means 3 or 5. Okay. So this is the vernier caliper, and the next apparatus is the traveling microscope. You could see the traveling microscope here. I said the least count value is, this is the same least count value for the screw gauge. So it is in 0.01 mm, but here the readings are entered as centimeter. So we have, for our convenience, we take that least count as 0.01 mm is equal to 0.001 centimeter. Okay. And this is a vertical scale, and there is a horizontal scale. In both vertical and horizontal scale, see, this is the horizontal scale and this is a vertical scale, and in vertical scale this is a main scale and this is the vernier scale. Okay, this is the main scale and this part is the vernier scale, and here this is the main scale and that small part is, it is written as vernier. So this is the vernier scale. So in that is in traveling microscope, if you look into the traveling microscope, you can easily find out this number of divisions in the vernier scale. So it is given as, so it is marked as 0.123 something like that. So you forget the decimal and take that arrow mark, very first line as 0 and 0.1 as 10, 20, 30, 40, 50 division. So total number of divisions in the, that is traveling microscope is 50 division. So for traveling microscope, the least count value is 0.001 centimeter. And the same formula what we use for this vernier caliper, you have to apply it here. So the least count formula is, what is the least count formula for this vernier caliper? That is value of 1 MSD by total number of vernier scale divisions. You know the least count value because already I told. So 0.001 centimeter. So the least count is 0.001 centimeter. You don't know the numerator value of one main scale division, but you know that is the, when you look into the apparatus, you can find out this vernier scale division easily. That is some x divided by 50. So least count. So if you cross multiply these two, you can get the numerator, right? Or if not, when you look into the apparatus, so 1 centimeter contains in main scale, that is the main scale, or 1 centimeter is equal to, it is written as 0, 1, 2, 3, something like that. So in between 1 centimeter, we have some 20 divisions. So 1 centimeter is equal to 20 division. So the value of 1 division in main scale. So 1 division is equal to 1 centimeter divided by 20. That is equal to 0.05 centimeter. So if you substitute that value, so 0.05 divided by 50, that is equal to 0.001 centimeter. So that is the least count value I told. Okay. So like that you have to find the least count value. And for spectrometer, the same procedure you have to follow. I didn't bring the spectrometer. I said that is the first 3 apparatus, that is screw gauge, vernier and travelling microscope, having the linear scale. That is the only apparatus having circular scale is nothing but spectrometer, and I told that is the least count value is 1 minute. And now I will explain. That is Young's modulus non-uniform bending method. That is the first experiment. So by using this non-uniform bending method, we have to find the Young's modulus of the given material or given rod or beam or scale, whatever it may be. This example. So this is knife edges, these two are the knife edges, and this is the beam or scale. Okay. So this is the pin or needle, and you have to apply the load here. So by using this weight hanger, we have to apply the load at the center or the middle. So this is the diagram, and I will show in the demo. So these are the knife edges. So you have to place the scale, uniform rod or scale like this, and so the length, that is, keep the length as minimum 70 centimeter or 80 and 90, something like that. Okay. So I have to add the load. So by using this traveling microscope, we have to focus the needle first. Okay. So this is a setup for this Young's modulus, and there is a formula to find the Young's modulus value. That is the Young's modulus taken as E. For there are two different methods other, that is non-uniform bending method and uniform bending method also there. So for non-uniform bending method, the formula is mgl cube by 4b d cube y Newton per meter square. So this is the formula to find the Young's modulus by non-uniform bending method. So you have to explain what is M, what is G, and what is L. M is nothing but the load applied, and G is the acceleration due to gravity. So its value is 9.8, and L is, don't write as L is the length of the rod, because the length of the rod is usually 1 meter. This is a 1 meter scale or 100 centimeter. So you have to write length is nothing but the distance between the two knife edges. Okay. So that is the L value, and by using screw gauge and vernier caliper, we can find the breadth and thickness. Okay. So no need to write one by one. So M is the mass applied, acceleration due to gravity, and L is the distance, but it's very important, and you simply write it as length of the scale means it's wrong. So L is the distance between the two knife edges, and B is the breadth of the scale, and D is the thickness of the scale, and Y is the depression. So what is the difference between this non-uniform bending method and uniform bending method? So this is a setup for this non-uniform bending method. And for uniform bending method, I had to apply weight at the both the ends. Okay. So if I add weight at its center, look here, if I adding next another, this is the dead load. If I add another 50 grams, so definitely the scale undergoes some bending. So there exists some bending, it undergoes some depression, something like that. Okay. So this is for non-uniform bending. So weight is added at its center or middle, the scale undergoes some depression. So we have to find Y is here nothing but the depression. Okay. So what is the difference between this non-uniform bending method and uniform bending method mean? So by adding weight at its center, what will happen? That is the scale undergoes some depression or bending. So the displacement doesn't cover an arc of a circle or elliptical path, that is nothing but non-uniform bending. So by adding weight at both the ends, so there must be some elevation. The scale goes like this, comes like this. Okay, by giving load at both the ends. So the displacement covers an arc of a circle or an elliptical path means that is nothing but uniform bending method. So that is the main difference between the, don't say that is the difference only. Weights are added at both the ends, here weight is added at the middle, and then it undergoes some depression, there exists some elevation, that and all okay, and you have to give the correct definition for this. So if the displacement does not covers an arc of a circle, that is non-uniform bending method, and the displacement covers an arc of a circle, that is called as uniform bending method. And there is a different formula for this uniform bending method, that is, this is for non-uniform. And similarly for uniform bending method, once again the unit is Newton per meter square. So what do you mean by this is Young's modulus? So you know three type of moduli, one is Young's modulus, and then rigidity modulus, and then bulk modulus. So modulus is nothing but what? The ratio of stress to strain. So what is stress? Force acting per unit area. And what is strain? By giving some stress, what will happen? There must be some change in dimension. So strain is nothing but change in dimension by original dimension. So there is no unit for strain. If it is meter or centimeter, get cancelled. So only we have the unit for stress. So stress by strain. So that is, so modulus, Young's modulus is equal to Newton per meter square. And this is for non-uniform, this is for uniform bending method, okay. And there is a tabular column for this both uniform and non-uniform bending method that we will see it in the next class, okay. So we will wind up the session, and thank you for listening. Thank you all.